describe the function transformation for each function you see. The first function is f of x equals to x squared minus 8. So what is the minus 8 mean? So the minus 8 is you have x squared, the minus 8 is not right next to x. So if you have an x squared, so 1x squared, you square x, and then whatever the product is, you minus 8. So the minus 8 means you shift the parabola 8 units down. So that is 8 units down. All right, so how about the next function? The next function is you have x minus 2, you raise that to the third power, and then you negative the entire function. So first of all, what is the negative mean? You negative the entire third degree. So when you put a negative in front of the entire function, that creates a reflection in the x-axis. So this is a reflection in x-axis. And then what about the minus 2? The minus 2 is inside the parentheses. So if the minus 2 is outside of the parentheses, like here, if I put a minus 2 in here, that is shifting the third degree 2 units up. But if you put that right next to the x, that is shifting the function 2 units to the left or right. The answer is 2 units to the right hand side. So the 2 is 2 units to the right side. It is good if you can like number the function for me, because you don't want the notes to be like all over the place, right? And then the next one, you have a plus 6. So this time it's not a minus, this time it's a plus, and then a minus 10. What is the plus mean? Plus is 6 units to the left. So this is a 6 units left. And then the minus 10 is outside of the parenthesis, and then that is 10 units downward. Now, the next three functions in yellow, these are tricky problems. So let me switch to yellow. So the first one, what is this? The first one, you have the square root of negative x plus 5. The plus 5 is easy. That is shifting the square root function 5 units up. But what happened when you put a minus in right next to the x? So do you still remember that the square root of negative is undefined? So this time for the square root of negative x for this term itself, if you let x equals to negative 1, x equals to negative 4, it is undefined, right? The square root of negative 1 is undefined, the square root of negative 4 is undefined, right? So therefore, since there is an x right next to the x, you will have to plug in x values. Agree? So you will have to plug in x equals to negative 1, x equals to negative 4, x equals to negative 9, so on and so forth. So when you start plugging in x value, I will just draw a quick picture for you. So when you start plugging in x value, do we agree that that is referring to the second or the third quadrant, right? So since you put a negative right next to the x, that creates a reflection in the y-axis, and then the plus 5 is 5 units up. So let me go ahead and erase this. I will put a reflection in y-axis, and then 5 units upward. All right, so the next problem is what happens if you put the 5 inside the radical? So the way I think about this is, if you are just thinking about the square root of x, the square root of x starts at the origin, right? And then go like this. That is the square root of x. So if you put when x is equals to 0, y is equals to 0. And then in the previous problem, I said that if you put a negative right next to x, that creates a reflection in the y-axis. So that means you have to flip the curve over to the second quadrant. But what happened when you put a 5 to it? Is the 5 still shifting 5 units to the left? Because this minus is plus 5 still shifting the square root function 5 units to the left. So you have a plus 6. Do you see this? You have a plus 6 right next to x. You said that is 6 units left. But for square root, if you have a plus 5 or plus 6 as well, is this still the left? Can you think about that? So what happened when x is equals to negative 5? When x is equals to negative 5, you have a negative 5, which is 5 plus 5 equals to 10. So y is definitely not equals to 0, right? What happened when x is equals to 5? Think. when x is equals to 5, do we agree that we have a square root inside the, do we agree that we have a 0 inside the square root when x is equals to 0? So therefore, you will have a point right here. So when x is equals to 0, y is equals to what? Y is equals to -5. When x is equals to 5, y is equals to 0. So when x is equals to 5, y is equals to 0, plus the reflection in the y-axis that we just talked about. So we have the curve right over there. So the plus 5 is shifting the square root function, or shifting the curve 5 units to the right. Again, the plus 5 is shifting the function 5 units to the right. This is a clear comparison between the square root and the square. So for the square plus, easy, to the left, right? Plus 6, 6 units to the left, plus 6,000, then 6,000 units to the left. But for the square root, this plus 5 is to the right. Look, to the right. So let me go ahead and erase this. Let me go ahead and cut this, and then we will write this down. So first of all, you have reflection in the y-axis. So reflection in y-axis, and then the plus 5 right over there is 5 units to the right. So you start at, when x is equals to 5, y is equals to 0. The graph looks like this. You start at 5. So 5, and then you have graph that looks like this. Okay, so what happened when you switch the plus 5 to a minus 5? Let's see. When you switch the plus 5 to a minus 5, so first of all, the minus x is a reflection in the y-axis. So for this problem, first of all, you create a reflection in y-axis, right? And then the minus 5, and then you might compare this to the previous problem, and then you say, okay, the previous problem, the plus 5 is to the right, the minus 5 is to the left. Okay, you can think that way because you have both cases. So the minus 5 in this problem is 5 units to the left. That is right, you get perfect score for this, but can you think deeper? What is the graph look like? So this one, can we let x equals to 5? When x is equals to 5, you have a -10. No, nothing is defined, right? So you have to let x equals to -5. So when x is equals to -5, what happened? So when x is equals to -5, you have a minus -5. That becomes a plus 5. 5 minus 5 is equals to 0. So when x is equals to -5, I should say that the curve start at x equals to -5, y equals to 0. So this is the y-axis. You already have a reflection. This is a -5 comma 0, and then the reflection and the graph. All right, so this is a little bit tricky because in the second power, the third power, usually the minus is to the right, the plus is to the left. But for square root, think carefully. Okay, so moving on to the next problem, we have f of x equals to 3 times absolute value of x minus 1 plus 2. So clearly the 2 is 2 units up. The minus 1 is 1 unit to the right, but what about the 3? So this one is c equals to 3, right? So you have a c equals to 3, and then c equals to 3 is outside of the absolute value, which is greater, and it is greater than 1. So that creates a vertical stretch. Now, I don't really like the words vertical stretch because that is confusing. When I say vertical stretch, what kind of picture do you have in your mind? So if you have a very helpful description that you want to share with other viewers, write a comment. So leave me a comment so other people can see it. So this one, I would say the vertical stretch is pretty confusing. What I picture in my mind is I have 3 times a straight line. So 3 times straight line, that means I am making the lines very steep. So the absolute value looks like a V. So the V should be very steep. As x increases a little bit, y increase a lot. So you should see a very steep V. like that. That looks like parabola, very steep V. If you change the 3 to a 1/3, you should see something like this. It's not so steep, it's pretty wide open V. All right, so how about the -1? The -1 is what? Is 1 unit, right? So the -1 is 1 unit, right? And then the +2, the +2 is clearly 2 units up. Okay, so this problem is done, and then the next one you have a -2. So the -2, the negative creates a reflection immediately, right? So the -2, so the negative, I should add this because eventually you won't see the function anymore. So f of x equals to -2, and then x plus 1, and then -15. Maybe I should do this. I should change this to a different color, change this to a green negative, and I'm going to point at this negative and say a reflection in x-axis. Still remember the graph of absolute value. The absolute value looks like this, always positive. If you put a negative, then that creates a reflection, then the absolute value looks like that. And then how about the 2? The 2 is greater than 1, right? So it's greater than 1, so this is also a vertical stretch. I won't picture, the best way to picture vertical stretch is like a very steep V. If you change that to a 1/2 or 1/12, that will becomes a wide open V. Very steep versus less steep, just to compare the slope. And then what else? The -1 is 1 unit to the left, so the +1. So this is a 1 unit left. And then the -15 is 15 units down. Okay, this is done, and then we have 2 blue problems to go. So let me just copy the function. You have g of x equals to absolute value of 2x. So this is inside. The 2 is inside. So this 2 is inside the absolute value. And then c equals to 2 is greater than 1. So this becomes a horizontal string. This becomes a horizontal string. That's all you have to say. Horizontal string. So here is what I mentioned in the previous video. The horizontal, vertical, stretch, and string is pretty confusing. I don't really like this word. If you put a 2 right next to x, you will just make the V very steep. If you change that to a 1/12, that will becomes a wide open V. Okay, let's finish the last one. The last one is a g of x. So you change the 2 to a what? To a 1/10, right? So 1/10 x. Look, this is a c equals to 1/10 is inside the absolute value. So that creates a horizontal string. What does that mean? Compare the slope 1/10. The slope that must look like this, compared to the very steep V. Alright, so that is the end of this video. If you like the way I explain it, give me a thumbs up, a subscribe, and I will meet you all in the next lesson. Signing out.